Hello, ladies and gentlemen. Today we are going to do the Troll Lab, and we're going to illustrate the relationship between impulse and momentum by using this old-fashioned 70s style troll doll. We are going to use our computer, and we're going to use an application called Pasco Capstone, which we'll open up in a minute. And that application connects to a control box, with these wires in the back, or the computer connects to the control box. And this control box is then connected to this piece of equipment here, which is a force sensor. This will pick up force of push or pull within a reasonable amount. Again, this is called Pasco equipment. There are other kinds of physics equipment manufacturers out there. I don't want to just say we only use this, but when you do physics in other schools or colleges, they'll use this or combinations of equipment. This is older equipment. The newer stuff actually is connected via Bluetooth or Wi-Fi, but we'll deal with the old hardwired lines. So what we do is we open the Pasco application. It's going to ask us several questions. Firstly, how do we want our data to look? And I'm going to pick table and graph form. And if you can't see this on your screen at home, I will zoom in on some of this and edit it in to the video. We first actually have to pick our hardware and connect the sensor we want to use. So use the side menu here, and we can say that we want to use the force sensor. So that's hooked up. And then I need to pick what I'm measuring, which would be force in newtons. And I want to do that force with respect to time, because as we know, force times time equals impulse. And then the same thing with the graph. I really have to denote, what kind of graph I want. And it shows a force versus time graph. So this is the table form of the data, and this is the graph form of the data. And when I hit click down here, when I click the record, it'll take readings every 0.05 seconds. So that's what I want to do. I'm going to hit record, and then you'll see the graph is moving across with respect to time. Now there's no force on the apparatus here, but it appears there is a force. So I'm going to come over here to the side button. It's a re-zero button. I'm going to get re-zero a little better. That's pretty good. It's picking up a static, but that's okay. And when I pull here on the bottom hook, you can see I'm making force. Or maybe you can't, but again, I will show you. On another, I'll edit it in. And of course, if I press upward, the force goes upward and positive. So I've made a graph with some force values. I'm going to, of course, they're going to ask me for an update now. Get rid of this. I'm going to delete this run. We don't need that run. So what we're going to do with this is I'm going to take the troll, and I'm going to connect the troll to the force sensor with a string, but I'm going to do that so the troll's upside down, and then I'm going to release the troll to fall and pull and then stop, almost like kind of a safety cord if the troll were falling to its doom, and the cord will stop it. So we're going to do that. We're going to see what happens with that data. And that's going to speak to impulse and momentum, right? By the very end of this fall, the troll's going to have momentum, maximum momentum, because it's gaining speed as it falls. But then suddenly, it's yanked to a stop. So this force impulse due to the string has to stop the momentum of the troll. We're going to do the same thing with the rubber band as a second run. We're going to hold the troll upside down. We're going to let it fall. We're going to let the rubber band catch the troll. And notice that the rubber band and the string are roughly the same length. So the troll should have roughly the same speed, and therefore the same momentum when either the string or the rubber band begins to stop the troll from falling. And so I'm going to go to the other side here. Okay, so we need to do this with the troll and the string. So we're going to get the troll, again connected to the force sensor. We are going to, I'm going to reach across, I'm going to start the run. I'm going to reset the scale to 0. I'm going to drop the troll, take this off, and hit stop. And in the graph, there's a decent spike. I don't know if you can see it. There's a decent spike around 5 seconds, which goes nearly 7 newtons of force in the string that spikes to stop that troll. And so now I'm going to redo it. I'm going to use the rubber band. And I'm going to, again, reach across. I'm going to just do a second run. If I hit record, it'll just do a second run. And I'm going to be a good scientist. I'm going to re-zero it. Drop the troll. Take the troll off. And I'm going to stop it. And you'll see, you can't really see, there is a little spike. It goes to about 3 newtons. And then there's a secondary spike because the troll was bouncing. But we're going to stop just at the first spike. We're going to analyze that. And so I'm going to analyze that data by, I'm going to screen record and talk to you about it and show you how this data works, and you're going to try to understand what this data means. Okay, thank you. Okay, so we have to analyze this data. What I'm going to do is I'm going to quickly cut away a lot of the data that we don't need in this. This is the run with the rubber band. What we will do is like I said, this is the run with the rubber band. What we're going to do is show run 1. Now run 1 is with the string. Cut away a lot of this old data. So I can tell that between 0 and nearly 5 seconds, there's a lot of just dead data up here. So if I go all the way up here, I can go from here and go to about 5 seconds, which is about here. All right, I gotta go. And I can get rid of some of that data. And so I'm right on the spike. And then what I'm going to do is I'm going to get rid of a good amount of this data from, and we can zoom in and move this around a little bit. We can stretch it out a little bit so we can get a better look at it. And so about here, I'm going to just take that first spike, because these secondary spikes are when it was bouncing around. So this first spike is what's most important to me, that first initial shock of the troll being stopped. And so we're going to about 5.2 and a little bit after 5.2 seconds. So we're going to go to about here. That's 5.35 seconds. And we can cut away a lot of this data. We don't need that data. Why did not let me do that? Hold on. So we'll go back here. Cut away a lot of that data. So we're left with just the initial spike, and I'm going to stretch this out a little bit so we can get a better idea of the timing here. And so you can see down here, this is from 5.00 to 5.25, so each of these is worth 0.05 seconds. So it took about 0.05 to 0.1 seconds for this first initial shock to happen, and it went down to about 7 newtons. Now, I can use area under the curve, and the area under the curve is negative 0.38 newtons per second. Well, area under the curve of a forced time graph is impulse. Force times time is impulse. This is a forced time graph. So it took about 0.38 Newton seconds to stop this troll using the string. It took about 0.1 seconds to do it And it took about 7 newtons, a little less than 7 newtons of force to do it in that time frame. Now I'm going to compare that with the rubber band run. And there's a lot of dead data here. We're going to go, we can see that we can go to about 5.5 seconds at least. So we can get rid of a good amount of that starting data. So here we go, 5.5 seconds roughly. So we can chop away this. We don't need this. And we do want that first bounce. And we can get rid of the data, pretty much any of the data after this time. You don't need to go away. So about 6.2 seconds. 6.2 seconds. So anything after 6.2 seconds we really don't need. So bear with me. And we can get rid of this. We can stretch this out. And so now we're looking at the time. And again, I want to compare that with the time that it took with my other. So I want to see if I can get the scale about the same. So we went from wow. Okay, so we went from, it made the scale roughly the same. So 5.1 to 5.2. So this is so 5.8 to 5.9 to 6.0. So notice here it took much more time. It took almost double the amount of time with the rubber band. And obviously it's a lot less newton. So if I do the area under the curve here, negative 0.40 newton seconds. Well, what's significant about that? We have negative 0.40 newton seconds to stop the troll here. And I can probably even cut that down a little bit because I have some extraneous information up top and up here, versus run 1, negative 0.38 newton seconds. What can we really say about those values? Are they very, very different, or are they nearly the same? And would it make sense? Should they be different, or should they be the same in this scenario? And that's really what you want to know. That's what I'm really asking you. So, analyze that data, answer the questions on the lab, and feel free to go through this video and look at it again and again. Again, here we go. Took twice the amount of time, not nearly as much force. The area under the curve is 0.4. It's a negative area. It's under the curve. That's only because the force is quote-unquote negative. And then, of course, that was with the rubber band and with the string. Area 0.38, negative 0.38, only 0.1 seconds, but the force is much greater. Okay, think about that and answer the questions, and turn in the lab when I ask you for it to be due. Thanks.